Meteorology. And as we have our first person, Tariq Masood sir. He has taken his first session yesterday on regression analysis. And today, sir is going to conduct his session on time series analysis. So, sir, I'm handing over the platform to you. Please continue with your session.
Okay, thank you, Dr. Anna. Okay, is it visible now? My screen?
Yes, sir. Yes, sir, it is.
Okay, so my today's lecture will be basically, it will be in continuation of the last lecture. Okay, so in the last lecture, we covered almost the whole story of regression analysis. Okay, in a sense, it was a complete story until and unless there is violation of any one of the assumptions that we had discussed in some early slides. So as I said that behind regression analysis, there are number of assumptions. Okay, so we assume a lot of things about the nature of disturbance term.
Sir, please unmute yourself.
Hello.
Tariq, sir. Yes,
okay,
sir.
Am I audible?
Yes, you're audible now.
Okay, so basically this lecture will be in continuation of the last lecture. In the last lecture, we covered almost everything that comes under the domain of regression analysis. So we can say that it was a complete story until and unless there is violation of some assumptions. Okay, so we had discussed that behind regression analysis there are number of assumptions. So we assume number of things regarding disturbance sum, few assumptions regarding x variable. Okay, so if all those assumptions are well satisfied, so then there is no need of doing any further exercise. You can you already know how to formulate your model, okay, how to estimate it by using OLS method. Then we can use R square coefficient of determination for judging the goodness of fit. Okay, then we can conduct hypothesis testing. There are basically two types of hypothesis tests. One is individual test of individual coefficients by which we can get whether individual coefficients are significant or not, and then we can conduct joint hypothesis testing. Okay, so once you conducted hypothesis testing, you can use estimated parameters for your purpose. Purpose may be, it may be policy making, it may be forecasting, for whatever purpose you can use that. But if there is violation of any one of all those assumptions, you need to further modify your model. There is need of modification. Okay, so first issue that we will discuss is the violation of homoscedasticity assumption. As I said that there is one assumption which says that variance of variability of disturbance term is constant. Okay, there is no change in variance of disturbance. If variances are not constant, like if variance of ut is equal to, suppose it is sigma t or sigma I square. Generally variance is a fixed value, it is sigma square, but t meaning of t is that it is variable. T may be 1, 2, 3, 4, and if you are using subscript I, okay, if you are using cross-sectional data, so in that case it will be I is equal to 1, 2, 3, 4, 5, okay, and so on. So This means that variance is variable. If variance of ut is equal to sigma t square, then it is variable. There is change in variability of disturbance term over the values of x and y. Okay? Okay, this is graphical representation. On y-axis we have y variable, on x-axis we have x variable, and this is scatter diagram, simply scatter diagram. Now we can see that the relation is quite stable. There is no change in the variability of disturbance over the values of x as we are moving along x-axis. The variability is almost same. Okay, so this is case of homoscedastic variances. This next figure, there is change in variability. Initially, there is very little variability, but as we are moving over the values of x, there is increase in the variability of disturbance. So, this case of heteroscedasticity. Okay, now suppose we have heteroscedasticity in our data. Okay, suppose there is change in variability of disturbance. What are the consequences of that? Okay? Now, if there is heteroscedasticity, the OLS estimators are still unbiased and consistent. Okay, you know all these properties. We already discussed that OLS estimates satisfy number of desirable properties. Okay, so even if there is heteroscedasticity, OLS estimates are still unbiased and consistent. This is because of none of the explanatory variable is correlated with the error term. So due to that, there is no correlation. Still, there is no correlation between x and u. So a correctly specified equation will give us values of estimated coefficients which are very close to the real parameter. They are unbiased basically. Expectation of beta cap is equal to true parameter beta. Okay? Now it affects the distribution of estimated coefficients, increasing the variances of distribution and therefore making the OLS estimators inefficient. We know that OLS estimates are efficient estimates. Okay, they have minimum variance, but if there is heteroscedasticity, they are no longer efficient, they are inefficient. Okay, now due to that, due to inefficiency in OLS estimates, there will be underestimation of variances of estimators leading to large values of t and f, because when we derive t and f statistic, okay, particularly t statistic, we know that t calculated is equal to beta cap divided by standard error of beta cap. Now there is change in the variance, there is change in the denominator. Okay, and generally there is increase in the denominator due to heteroscedasticity. So due to increase in the denominator, okay, there will be underestimation of the calculated value. You will get less calculated value, less than the true t value. You will get less low value of t calculated value. Okay, so next is how to detect it, detect this problem, how to know whether there is change in the variance of disturbance term, and then next is solution. Once we ensure ourselves by empirical testing that there is heteroscedasticity, there are some suggestions for removing this problem. Okay? For detection, there are two ways. One is simply using graphical methods. Okay, so by graphical method, we can get a sense of what is happening. We can look at graphs, various graphs, to ascertain whether there is change in variability of disturbance term or not. Okay, and one point is that basically all these assumptions are about disturbance term, about the u. Okay, but we have no data of u. We doesn't know about u, about disturbance term. Ultimately, you have to test all those assumptions on the basis of sample data, sample residuals. So this is one problem when it comes to testing of assumptions, because assumptions are basically about population, and we are torturing our sample too much. We are estimating parameter, we are conducting hypothesis, and we are also testing population assumptions on the basis of sample data. So this is one issue. Okay, now after graphical method, there are a number of formal methods for it, for ascertaining the exact magnitude of the problem. Okay, for establishing proper relation between u and x variable. Bruce-Pagan test, Glaser test, Harvey-Godfrey test, Park test, Goldfield Quant test, White test. There are a number of tests, okay, battery of tests that you can apply, and application of all these tests is quite easy due to availability of statistical software. There is no need to go into too much detail for you. Okay. I will basically discuss graphical methods, and due to time constraint, I will leave formal method because we have to cover a lot of things in this lecture. Now, first graphical approach is to plot UI square residuals on either over the values of y cap or x. Okay, so you can use x variable on x axis. You can use either y estimated y, predicted values of y. Okay, or you can use x. Okay, now if you get such type of graph, okay, this is a case of homoscedasticity. There is no change in variability of u cap over the values of x. So this is a clear case of heteroscedasticity. Again, variables are same, okay, and there is change in variability. Initially, there is very little variability, and over the values of y cap and x, there is increase in the variability. Now here again, variability is same. Okay, so this is homoscedastic case. There is no change in variability. Now in this case, there is change in no, there is no change. Even in this case, there is no change in variability. Variability is almost same. Okay, although there is a turning point, but the variability is almost same. It is within the range. Okay, this is again. Then you can apply number of after doing this graphical approach, you can also apply all those tests. Okay, and in statistical software, you will directly get p-values of the calculated statistic. So there is no need to go into any detail in that sense. Ultimately, you will get p-value. On the basis of p-value, you can decide whether there is homoscedasticity or not. Now, once we find that there is heteroscedasticity, there are few solutions. One is A and B are almost same. There is a very minor difference, but you can use weighted least square, where we generally use weight as UI cap square. So we divide the whole equation up. First we estimate the equation, we derive UI cap square, and then divide the whole equation by UI cap square. So we use UI cap square as weight, and then we do weighted regression. Okay, so that is known as weighted least square. analysis. In statistical packages, there is an option of heteroscedasticity consistent estimation method. So once you click that option, you will get corrected variances. Basically, it causes problem in variances of estimated coefficient. So heteroscedasticity consistent estimation will correct that problem. Okay. Now, most of the time we face this problem in the context of sample data, but it may be present in the time series data, but mostly it is in the context of cross-sectional, large cross-sectional data. Now, next is problem of autocorrelation. There may be violation of this assumption. We assume that there is no autocorrelation. There is no correlation among successive values of disturbance term. So, for example, you have two disturbance term UT and US. Their covariance or correlation is 0. Okay. If there is a violation, it does not equal to 0. That means there is a problem of autocorrelation. Okay. If this assumption is no longer valid, then the disturbances are basically interdependent and but pairwise autocorrelated. This means that an error occurring at period t may be carried over to the next period. So ultimately, there is a transmission of a disturbance term in one phase to other time period. Now, it occurs mostly in the time series data because as I said earlier, that one important difference between time series and cross section is that you can disturb the arrangement of cross sectional data. And in case of time series data, there is a natural ordering. You cannot disturb that. So due to that, there is suppose there is a correlation between successive values of u. You cannot disturb that. You cannot change the order of data. But in case of cross-sectional data, you can change that order. So ultimately, there will be removal of such type of correlation. Okay, now why there is autocorrelation? Why there is a problem of autocorrelation? What are the causes? Causes are, first cause may be omission of any important variable. So as I said that we have to specify our model properly. We have to include all the important determinant. But if by mistake you dropped any important variable from your model, that effect will go into UI, and UI will start behaving systematically, and there may be autocorrelation due to that. Next is functional form. Okay, suppose the true functional form is y is equal to beta 1 plus beta 2 x square, but suppose wrongfully you assume that the model is yt is equal to, it is a linear model. You assume that it is a linear model, but in reality the model is non-linear model. So again, there will be a systematic behavior of UT, there will be autocorrelation. Third reason may be systematic errors in the measurement. There is continuous error in any measurement process. This may cause autocorrelation. Okay, now what are the consequences? The OLS estimates are still unbiased and consistent, like in case of heteroscedasticity. This is because both unbiasedness and consistency do not depend on this particular assumption that is violated. OLS estimators will be inefficient and therefore no longer blue. Blue is best linear, unbiased and efficient estimator. OLS estimators are best linear, unbiased and efficient. But if there is autocorrelation, they are no longer efficient. Okay? Now the estimated variances of the regression coefficients will be biased and inconsistent, and therefore ultimately it will cause problem for hypothesis testing. In most of the cases, R square will be overestimate the T statistic tend to be higher than normal values. Again, for autocorrelation, we have two methods, graphical and formal methods. Now, you can plot, simply you can plot values of residuals over the X values. Okay, if there is any systematic behavior, okay, or sign of systematic behavior, you can say that there is autocorrelation. Or you can plot a scatter diagram between current residual at time t and residual at time t minus 1. Okay, with this scatter diagram is basically for looking for correlation dimension. So once you plot scatter diagram between ut and ut minus 1, you can get a sense of autocorrelation. In this case, there is autocorrelation. In this particular case, this graph shows that there is autocorrelation. As there is an increase in the values of first residual at time t, there is increase in the values of residual at time t minus 1 or t minus 2. Okay, so this problem arises in case of time series data. If you are using time series data, there is need to check for autocorrelation. Okay, and if there is autocorrelation, there are number of solutions, but we will also be discussing time series properties in a while. So there we will discuss about unit root and the solution of unit root and autocorrelation. Sometimes there is same solution, okay, log differencing or simple differencing. So I will discuss about the solution of autocorrelation there at the time of time series analysis. Okay. Now next assumption that matters for regression analysis that needs to be tested is assumption of multicollinearity when we are dealing with more than one variable. It does not arises in case of simple regression, but when we have more than one variable, there may be problem of multicollinearity. The assumption is there should not be any exact relationship between X variables or among X variables. Okay, so if there is an exact relationship, this is known as perfect multicollinearity. When there is an exact relationship between, suppose, x1 and x2, that is a case of perfect multicollinearity. Okay, so under perfect multicollinearity, you cannot estimate coefficient, all the coefficients. Okay, the Euler's estimators simply do not exist because due to perfect relation between x1 and x2, suppose x1 is equal to 2 times x2. This is the case of perfect correlation. X1 is equal to 2 times x2. So for regression purpose, even though you are adding two different variables, they are basically same. There is no difference in the variation of x1 and x2. And regression analysis is basically analysis of variance, okay, variability. So the variability of x1 and x2 is same. Even though x1 is equal to 2 times of x2, the overall variability is same. So in statistical sense, both the variables are same variable. So if they are same, we cannot get all the coefficients. We cannot get beta 2 and beta 3 or beta 1 or beta 2, their respective coefficient. Okay? And if you are using software, you will get an error message, or sometimes software automatically drops one variable because they are same variable. There is perfect multicollinearity. Software will suppress one variable and estimate by using remaining variables. Okay? This is the case in data. If you are doing regression analysis in data will drop that variable. Okay, now the more reasonable scenario is when perfect multicollinearity is a very rare situation that you with the real data, with the observed data, it is extremely difficult to get such scenario where there is a perfect relation between any two independent variables. But sometimes we use variables, independent variables that are highly correlated. There is high correlation between any two variables, two independent variables, or maybe more than two, involvement of more than two independent variables. Okay, so that is a case of imperfect multicollinearity, or we also called it near multicollinearity. Near multicollinearity. Okay. So in case of near multicollinearity, the OLS estimators can be obtained, and they are also, you can get estimates. There is no problem with respect to estimation. Ultimately, you will get some values of estimator, and they are blue. They are best, linear, unbiased, and efficient. However, the OLS variances are often larger than those obtained in the absence of multicollinearity. So there may be slight increase in the variances of OLS. Okay, now this is you can get a sense of multicollinearity, imperfect multicollinearity, by this formula. In the presence of multicollinearity, variance of beta 2 coefficient or beta 3 coefficient is equal to, the formula for variance is sigma square divided by summation x2 minus x2 bar square. Okay, but when there is a correlation, we also add this factor 1 minus r square. Okay, so when the value of r square is suppose 0, when this r is correlation between x1 and x2. Okay, so when or in this case x2 and x3, because their variable is x2 and x3, they are using beta 2 beta 3. So this is basically r square is, or r is correlation coefficient between these two independent variables. If there is no correlation, if the value of r is 0, this whole value is equal to 1, and we have formula of variance sigma square divided by summation x2 minus x2 bar square. Okay, but if this value is suppose r is 1, when there is a perfect relation between x2 and x3, r is equal to 1, and this whole value is 0. So when we divide sigma square by 0, the denominator is 0. So you will get infinite value, infinity. So that means we cannot determine those. This factor is in case of involvement of more than two explanatory variable, you can use rj square, capital R. You know difference between small r and capital R. Okay? Now this factor 1 upon 1 minus r square is known as variance inflation factor. We call it variance inflation factor, and by using this concept, variance inflation factor and estimated value of variance inflation factor, you can get a sense of multicollinearity. If the value of VIF is more than 10, the rule is, if the value of variance inflating factor, most of the software report this value VIF automatically, or you can choose options for getting VIF values easily. If the VIF is more than 10, when R square is more than 90%. This is the connection between VIF and R square, because VIF is nothing but 1 upon 1 minus R square. So when the value of R square is more than 90, 0.90, the value of VIF is 10. So more than 90% value of coefficient of correlation is a very high value. That means when VIF is more than 10, it is problematic. It shows that there is high correlation between variables. Okay? So you can use, simply you can use VIF, you can use graphical methods also. When no further points on consequences, when imperfect multicollinearity is present, estimates of OLS may be imprecise because of large standard error. Affected coefficients may fail to attain statistical significance due to low t-values because there is increase in the variance. Addition or deletion of few observations may result in substantial changes in the estimated coefficient. When we are adding few data or we are deleting some observations, there may drastic change in the estimated coefficient. Now, for as far as detection is concerned, simply you have to find correlation between two variables. Okay, so you can use a scatter diagram again for getting relation between two variables, either dependent and independent, or even between two independent variables. You can use a scatter diagram or correlation coefficient. Correlation coefficient between x1 and x2. Okay. Then you can use VIF, variance inflating factor. If the value of variance inflating factor is more than 10, we can assume that there is high correlation. Okay, now coming to solution of this problem, solution of multicollinearity. There are some classical solutions that we can use, especially designed ridge regression, or you can use method of principal component. So I think you know about this method of principal component or factor analysis. What we do in principal component is to it is basically a data reduction technique. When you have number of variables, okay, you can get a composite variable by using principal component method. So you can club number of variables into a new index, which is representative of all those variables. So in that way, you can significantly reduce a number of independent variables used in the model. This is one method, but there are number of problems involved with these solutions, because each and every variable matters. And as I said, that multicollinearity is basically a problem of data. It is not a problem of population. It is not a problem in theory. Okay, it is a practical problem that we face at the time of estimation due to data in hand. Okay, so any extreme solution may be problematic for that. So so there is suggestion by number of people that we should not do anything about multicollinearity, especially in time series data. But there are few solutions. You can also use these methods, hit and trial type methods. You can drop some or one of the collinear variable. If you are not sure about its participation in the model, if you does not have some solid theoretical background for that, and it seems that we can drop this variable, you can drop. Okay? But you should not drop any important variable from the model, because in that case there will be a specification. Transform the highly correlated variable into a ratio. Okay, so we can also do some transformation. There are a number of transformations. In place of original variable, we can use some transformed data. Okay. Now the third option is to collect more data, to add more data, but this solution is not possible in number of scenarios because we have limited set of observation. There is no way by which we can add more data. But if your context allows you, you can add some new observations, and addition of new observation, by adding new observations, you can get rid of this multicollinearity problem. If you are using time series data, you can also switch to higher frequency data. Like suppose initially you are using annual yearly data, you can move towards quarterly data, or if possible, you can move towards monthly data. Okay, so you can increase the frequency. Your objective is same. Okay, ultimately you have to establish a relation between the variables dependent and independent. You can use high frequency data for that purpose. And in the high frequency, sometime this basically hit and trial method. Sometimes you can get rid of this problem. Okay. Okay, so this is all about regression analysis. Okay, now we have discussed almost all the important things that comes in regression analysis. There are a few number of other things, interrelated things like treatment of qualitative variables. There are a number of other topics. So after this presentation, now I will take some time and I will do presentation on time series analysis. Okay, I have a brief presentation for time series data also. Okay, but before that, if you have any question, okay, you can ask me. The floor is open. You can ask any question regarding regression analysis. Anyone? Hello, am I audible?
Yes, sir.
Okay. Okay, now I will share a different slide. Is it visible?
Yes, sir.
Hello?
Yes, sir. Yes,
Okay.
sir.
Okay, now we will move
Yes,
towards
sir.
time series analysis. If you are dealing with the time series data, there may be some specific issues that we face only in the context of time series data. Now, this discussion is important because most of the time we deal with the time series data. Even if you are a student of economics, if you are working on international trade, if you are working on public finance, if you are working on macroeconomics, most of the areas are basically we basically deal with the time series data until and unless you are doing some research in the developmental field and you are going to the ground for primary service. Most of the time our data is basically time series data. So there is need to know few things that are specific to time series data. Okay? Now, time series data, time series econometrics, basically there is gradual development of time series econometrics, and during especially last 4 decades, there are a lot of development in the field, and now these models are very popular in the research papers. Okay, so one concept that is very important in time series analysis is concept of stationarity. Okay, a key concept underlying time series process is that of stationarity. A time series is a covariance stationary. Any time series variable is stationary when it has these three properties, three characteristics. If the mean is constant, first property is basically if the mean of time series is constant over the period of time. This is first property, and for stationary data, variance must also be a finite time invariant value, time invariant. There should not be any change in the variability of variance of the series over the period of time, and there is no change in covariances between variables, between observations. Okay. Now in notational form, first property is basically expected value of yt is constant. Okay, so when we say expected value, it is mean value. So mean of the data, mean of that particular series is constant for all time period. So variability is constant at different points of time. Okay, there is no change in the variability of data. Okay, and last property that is needed for stationarity is covariance between two observations, yt and suppose any other point yt plus k is constant for all t and all k shall equal to 0. That means covariance between suppose yt and yt plus 1 is equal to covariance between yt and yt plus 3, and these two are equal to covariance between suppose yt and yt plus 10. So there is no change in covariance over the period of time between any two observations. If all these properties are satisfied by any particular series, particular time series, we can say that the series is stationary. Otherwise, it is non-stationary. Okay? Now, why stationarity is needed? What is the need of this particular assumption? Now, problem is when any particular series is non-stationary. Okay, so there is accumulation of past disturbance term in that series, and due to that, the behavior of series is non-stochastic. Okay, there is continuous divergence of that series, and the behavior is not normal. Okay, and in the proper regression framework, when we use time series data for classical regression analysis, when there is involvement of non-stationary time series, okay, our regression analysis may be spurious. Estimated relation between variables may be spurious. Now the question is, what is spurious? What is the meaning of spurious? There is a concept of spurious correlation, and there is a concept of spurious regression. Now, as far as correlation is concerned, I can give you one example, that when we take data of Australia's human population and Australia's kangaroo population, what we see that there is a very high correlation between these two, human population and kangaroo population. So that does not mean that there is any relation. Okay, this is the problem of correlation. Someone has asked in the last class that why we do regression analysis. We can simply do correlation analysis and we can ascertain whether two variables. So this is the problem of correlation. Then when you are simply resorting to correlation, it does not say that there is cause and effect type relationship. They are related, they are moving in the same way, but there may be nothing like underlying relationship. Okay, so that correlation, such type of correlation, like correlation between human population and kangaroo population, this is a case of spurious correlation. Okay? Now, if uh, uh, time series variables are non-stationary, you can get a case of spurious regression. That means the data, the analysis will tell you that there is relation. You will get significant coefficients, and by applying everything that you have learned in the past 2 days, you will find that there is relation and there is significance of coefficient. There is a high coefficient of determination value, but still there is no underlying relationship due to presence of non-stationarity. Okay. This is in a more formal way. In a stationary time series, shocks will be temporary, okay, and over time their effects will be eliminated as the series revert to their long run mean. But if the series is non-stationary, there will be a continuous deviation. Okay, there will be a permanent effect of any particular shock. Time series is basically addition of shocks. When we go for formal derivation of uh, time series, yt is nothing, any particular value of time series, suppose GDP in 2010, any variable. Yt at time t is nothing but accumulation of all past shocks. So when the series is non-stationary, there is a permanent effect of any particular shock, and there is permanent deviation of the series. But in case of stationarity, shocks have temporary effect. There are a number of methods for ascertaining whether the series is stationary or not. We will discuss few of them. Now, the problem of non-stationarity is also known as problem of unit root. When a series is non-stationary, we say that there is a presence of unit root. What is unit root? Suppose any particular series follows this pattern, that the current value of series is depending upon the past values with phi as a coefficient, and plus ET, where ET is a pure random process, okay, noise component. The stationarity condition is the value of this parameter is less than. If the absolute value of this coefficient is less than 1, we can prove with the mathematical derivation that yt is a stationary series. But when the value of phi, when the magnitude of phi is more than 1, this is the case of non-stationarity, and there is permanent effect of any particular shock. Okay. Okay, if the value of phi is 1, okay, and you are subtracting yt from both the sides, you will get delta yt is equal to et, and et is pure random process. So yt is delta yt, by taking a simple difference, you will get a pure random process. Now a series is series yt is integrated of order 1 and contains a unit root if yt is non-stationary but delta yt is stationary. That means in raw form, in original form, there is a presence of unit root. Okay, the value of phi is equal to 1. Okay, but when we take first difference, delta yt, it is stationary. Okay, so this is the case of integrated of order 1, because after differencing one time you get a stationary series. In the original form, the series is non-stationary, but after taking first difference, we are getting a stationary series. This is the process method by which we make any series stationary. We can take differences. So suppose we are getting a stationary series after taking first difference. Delta yt is equal to yt minus 1. Then the original series was integrated of order 1. Now on the same line, yt is integrated of order d if yt is non-stationary, but taking dth difference is stationary. After taking dth difference, if the series is stationary, but there is no need to know all these cases. Most of the series are either integrated of order 1 or more, or it may be integrated of order 2 in few cases, but mostly there is the order of integration is 1. Okay, now we will discuss in detail the concept of spurious regression. As I said that when the time series variables are non-stationary, there may be spurious regression. We may be getting spurious coefficients, and all the significance may be due to presence of non-stationarity. A spurious regression usually has a very high value, high R square value, significant T values, okay, and model looks very good in the presence of non-stationarity. Now, most of the microeconomic time series variables or time series data are trended data. When you plot a time series data, you can easily look for the trend in that. Okay, so it seems that most of the time series data are non-stationary data, but in reality, the trend is of two types. One is which we call deterministic trend, okay, and other is stochastic trend. So here we are basically discussing stochastic trend. If the trend is purely deterministic, you can ascertain the magnitude of that by running some trend regression, like yt is equal to a plus b or beta 0 plus beta 1 t if it is a linear trend, or you can try some non-linear trends and then we can remove trend from the data. But if the trend is due to unit root, if the non-stationarity is due to unit root, if it is due to presence of unit root, that trend is basically a basically a stochastic trend, and we cannot ascertain the magnitude of stochastic trend by all those methods, by trend fitting method. The only thing is that we have to remove the trend, stochastic trend, by taking differences, either first difference, if there is if the order of integration is 1, if there is 1 unit root, we have to take 1 difference of the variable. If the order of integration is 2, we have to take 2 differences. Okay. The problem with non-stationary or trended data is that a standard OLS regression procedure can easily lead to incorrect conclusions. That is. Now, this was the experiment that was Monte Carlo experiment. Monte Carlo experiment means that we generate some hypothetical data. We can create a hypothetical condition, and then with the help of software, we can generate some hypothetical data with predefined properties, and we can test number of things by using that data. So Granger and Newbold constructed a Monte Carlo analysis generating a large number of YT and XT series containing unit root. So by default, there is a unit root. They generated data which contains unit root. of two different series, yt and xt. So now the benefit of this Monte Carlo analysis is that now we have data of yt and xt, properties of which are already known. We know the properties, we have generated, we have created them. Okay, so we know the underlying properties. Okay, and we, in this case, we know that there is a unit root in both the cases. In the case of yt is equal to yt minus 1 plus pure error term. So the value of phi is 1 and there is unit root. Okay, now again in case of xt, the value of phi is 1 and there is unit root. Now when they regress the various y's to x's by assuming y as a dependent, x as independent, they surprisingly found that they were unable to reject the null hypothesis of beta 0, beta 2 is equal to 0 for approximately 75% of their cases. That means they were getting sense that there is high relation between y and x. They were not able to reject, yeah, beta 2 is equal to 0. So ultimately they were concluding that there is very high correlation between x and y. But they know that there is no relation between x. And this relation, the failure to reject the null hypothesis is due to presence of unit root in both the cases. Both the cases, both the variables contains unit root, and due to presence of unit root in both the data, there is it seems that there is significant relation between y and x. Okay? In such scenario, you will get a very high R square values and very low values of DW. DW is Durbin-Watson statistics that we use for detection of autocorrelation. Okay, so on the basis of their experiment, they proposed that this following rule of thumb: if R square, the value of R square is greater than Durbin-Watson statistic, or capital R square very close to 1, then the regression must be spurious when we are dealing with time series data. If the value of R square is at the time of estimation, you can get values, all these values from statistical software, R square, Durbin-Watson statistics, everything. So you can compare. If R square is greater than DW statistics, there may be presence of spurious regression. So that means if your presence of unit root is causing spurious regression, there is need to detect that, there is need to repeat that, because it's a very serious problem. You are getting a very good result if after doing all the estimation and hypothesizing exercise, you are getting very good looking results. Okay, and then wrongly you can conclude that there is a significant relation between y and x, or between dependent and independent variables, but that may be due to presence of non-stationarity, due to presence of unit root. So there is need to know whether there is unit root, and if there is unit root, somehow we have to remove that unit. We have to use stationary data. We are only allowed to use, because we cannot do regression analysis which is based upon non-stationary data. So now next is how to test for unit. Okay, there are a number of tests, but here we will discuss only one and most commonly used test, Dickey-Fuller test for unit. Okay. Now for first order auto regression, that means yt is simply dependent upon yt minus 1. There is no higher order auto correlation if the series is following this simple path. Okay, so in this case we can test the test of unit root is basically test whether phi is equal to 1 or not. If phi is 1, that means there is unit root, and if phi is less than 1, there is no unit root. But instead of using this equation, we can use a transform equation. What you have to do, subtract yt minus 1 from both the sides, from left side and right side. So ultimately, after subtracting yt minus 1 from both the sides, you will get delta yt minus 1 is equal to phi minus 1 yt minus 1 plus ut. And then for this whole value phi minus 1, we can replace this by gamma, suppose by gamma. So delta yt minus 1 is equal to gamma into yt minus 1 plus ut, where of course this gamma is equal to phi minus 1. Now the null hypothesis, here now we can use null hypothesis as gamma is equal to 0. So when we are testing gamma is equal to 0, basically we are testing whether phi is equal to 1 or not, because gamma is equal to phi minus 1 is equal to 0. So when we are testing gamma is equal to 0, we are testing whether phi is equal to 1 or not. So if gamma is equal to 0, phi is equal to 1, there is a unit root. Okay. Now the alternate hypothesis is gamma is less than 0, one-sided hypothesis. Now there is you can use a little modified model. T.Q. Fuller again suggested that if there is higher order correlation, we can also add some higher order terms in the regression. So two things can be added. One is we can add constant and trend in the model. There may be presence of constant, there may be presence of trend. So you can modify. Simple model is delta yt is equal to gamma times yt minus 1 plus ut. When we add constant, we add alpha 0. When we add constant and trend, we add alpha 0 and a to t in the equation. Okay? And in augmented Dickey-Fuller model, apart from all those things, we also add some lagged values of dependent variable. So our dependent variable is delta yt minus 1. So we have to add some lagged values of delta yt minus 1. Now the null hypothesis is same. Null hypothesis is almost same everywhere. That in all the model we have written number of ADF representations, but null hypothesis is same for all the representations. The only difference is in the tabulated values. So when we add, suppose for example, alpha 0 or time trend or lagged values of dependent variable, when we are moving from simple representation towards more complex representation, there is change in the tabulated value. So it has effect on final say on either we are accepting the null hypothesis or rejecting null hypothesis. Okay? So in all the representations, you can look at the null hypothesis gamma is equal to 0. You can use that. In this case, the estimated statistic does not follow t distribution. That follows a different distribution, that is tau distribution. And for that distribution, tabulated values are being provided by the Dickey-Fuller. So you must use those tabulated values, not t values, simple t values. Okay. Now this is all that I will say in the time series lecture. Okay. Now, if there is time, still some time, I can do one thing. I can demonstrate a simple estimation exercise in one of the statistical software. Okay. So I think there is some time, still there is some time. So we can do one real exercise on statistical software. Before that, for understanding all these concepts, I will suggest that there are a number of books, textbooks. But in the Indian context, we use Basic Econometrics by Gujarati, and it is a wonderful book. So you can use Basic Econometrics. Title is Basic Econometrics by Damodar Gujarati. Okay. That is one book. You can also add, I am not sure about the exact title, but it is Econometrics by Ramu Ramanathan. And I find that book very, very wonderfully written. So you can also use book of Ramu Ramanathan. Okay? There are a number of books in the market you can use. Now, as far as application is concerned, statistical softwares are concerned, there are many softwares in the market, but mostly we use eViews, Stata, and now recently people started during last 6-7 years. There is use of R and other software, but for basic analysis, if you are not expert in the field, you can rely on eViews for time series analysis. So time series part is good in eViews. Okay, and if you are dealing with cross-sectional data, large survey data, or for example, panel data. So in that case, I think Stata is a better option. Okay, so Stata and eViews, you can learn these softwares for regression analysis or any statistical analysis. Okay, now all these software you have to pay. Either they are subscribed by purchased by your institution, there is an institutional license, otherwise you have to purchase your own copy. But there are few freely available options as well, and one option that is very good for early learners is Gretel, Gretel. It is a freely available on GNU platform, for open software. R is also freely available, but you can use Gretel for econometric exercise, Gretel. So now I will open Gretel, which is installed here in my laptop. Now,
Bueno.
okay, now let me share this. Okay, is it visible?
Yes, sir.
Okay, this is the software that I was talking about, Gretel software. Okay, now the good thing is that in the Gretel software you can add data of number of textbook, like book of Gujarati, Ramu Ramanathan, or Oldridge, or any other book. The data is also available on the same platform, data of textbook. Now here in the option file, open data, sample file. Okay, these are the variables, that data set that are specific to Gretel documentation. But I have added green. There is a book of green on econometrics, data of green, data of Gujarati, and data of Ramu Ramanathan. Okay, now take any one particular data set, suppose from Gujarati. So this first table is personal consumption and GDP. So there are only two variables. Okay, now we can select data where we have more than two variables, or independent variables of more than one. Okay, this table 7.3 is output, capital, and labor of Taiwan during 1958 to 72. Select that. These variables are now in the software. Y is a gross product, okay, overall product. X2 is labor and X3 is capital. We know about the this production function, that in production function y is a dependent variable and labor and capital are independent variables. We know that from economic theory. Now suppose we are trying to estimate production function. Our purpose is to estimate production function of this particular country, Taiwan, with a given data. Okay. Now first thing that I said that in the first stage, once you have clarified your objective, your hypothesis, you have to decide about the mathematical formulation of your model. Now with the theory, we know that this model is a non-linear model in mathematical sense. Okay. The most simple production formulation is of Cobb-Douglas. There are other production formulations, but even if you are using Cobb-Douglas production function, it is a non-linear function in original form. Originally, it is y is equal to beta 0 into k power L, k power beta 1, L power beta 2. Okay, and when there is a constant return, we know beta 1 plus beta 2 is equal to 1. Okay, so now suppose we want to estimate Cobb-Douglas production. So y is equal to, as I said, it is equal to beta 0, L power beta 1 and k power beta 2. Now first we have to make it linear, because in original form it is a non-linear function. So first task before formulating even econometric model, we have to make it linear. Now, can you suggest me how we can make this function linear? How we can make Cobb-Douglas production function linear? Anyone? Mainly from economics background. How we can make Cobb-Douglas production function? There is one response. There are few responses that we can take log. So once we take log, it is log y is equal to beta 0 plus beta 1 log L plus beta 2 log k, and then for econometric specification we can add u. So dependent variable is log y, independent variables of log of L and log of k. So first we must take log of all these variables, because we are not going to use original variables, nominal raw variables, but their logarithmic transformation. So select all the variables. Okay. First select all the variables, then under the option add, there is option logs of selected variables. So simply click on it, and there will be addition of 3 new variables, which are logarithmic transformation of original. First is log of y, then log of x2, and last is log of x. Now you have data in a proper form. Now you have variables in proper form, which we can use for regression analysis. We know that y is dependent, x2 and x3 are independent. So go to model, modeling, and under model, first option is OLS, ordinary least square. We are going to use OLS method. Okay. Now in the new dialog box, here we have list of all the variables available, and then in the right side there is option of selection of dependent variable and all the independent variables. So select dependent first. Now this is our dependent variable. There is some noise. I will suggest that you all mute yourself. There is some technical problem in my laptop, but let me be very clear that it is a very good software, and here once you select all these options, dependent and independent variable, you will get the final result in a very systematic framework. You will get all the estimated coefficients, you will get standard error, you will get t values, you will get p values, exact level of significance, then all the coefficients like r square, adjusted r square, you will get almost everything. Then in that window, in the result window, there is option of conducting further hypothesis. Okay? So you can use this Gretel, or you can use eViews, you can use this data. Is Dr. Anna, are you there? Hello. Okay, now if you have any question, you must feel free to ask regarding regression analysis or time series analysis.
There is too much noise in background, sir. Please.
Irfan Shahid, sir, please switch off
your camera.
Irfan
Shahid, sir.
Let me try to mute them all. Okay. Now, if you are facing problem, you can put your question in chat box also. Because I think host is not there. Okay, now you can ask. I think now you can unmute yourself. Hello. Hello. Yes, please ask. Now you can unmute yourself. Okay, someone has asked asked me to share data sets. The data set is available on Gretel platform. Okay, and that is in the format of Gretel. So first you have to install Gretel, then you have to install data of any particular book. Okay, and that will be directly installed, added into the Gretel. Then from Gretel, you can export that data to other formats. Like you need Gretel data in that particular data in Excel format. First go to Gretel, open that data, and from there you can export that data. Okay, so it is not available in Excel format. Basically, we all need data in Excel format, but it is not available in Excel format as far as I do. You can download it in Gradle format, and then after opening Gradle, you can export that data to any other format like eViews or Illustrator. Okay. Okay, someone has asked for the link. So let me try this. I will search for the link. Okay, you can follow this link. I have just sent it on the chat box. You can follow this link for downloading Gradle. There is a Windows based version. Okay, you can select that Windows version. Okay, so someone has asked about the brief of I think eView software. There is some spelling mistake. eView software. Now eViews is Gradle is basically a clone of eViews. You can say Gradle is a clone of eViews. In eViews, both the options are available. You can do regression analysis or any analysis on the basis of command line option. So there you can put commands and a bunch of commands, and then you can execute all those commands and you will get all the needed results. Okay, or you can do manually one by one all the exercise by using dialog box. So there is an option of dialog box in eViews. Dialog box is easy for early learners because we are not comfortable with the command system. So in the early stage, you can use dialog box option of Gradle or eViews. Even in the Stata, there is an option of dialog box. So you can initially you can use that, but I will suggest that you must move toward using command based method of using all these softwares, because the benefit is that first benefit is that you can do a lot of exercise in one go. You can write all the commands, then you can execute all the commands. You will get all the results. So suppose we need plot of a time, we are using any particular variable. We need plot time series plot of that line. Okay, we need unit root test for that variable. Then we need some regression result where more than one variable is involved. You can write all the commands, then in one go you will get all the desired output by using command system. Now next benefit of using command based method is that it is good for the reproduction of your result. So suppose you need to reproduce your result of after the gap of 1 year or 6 months. It's quite easy to follow your command line because you can save your command syntax file. Okay, but dialog box you cannot reproduce those things. Okay, so someone has asked about the eViews. You can use eViews easily by using dialog box. There is no mystery. There is nothing like rocket science. You just go there, download some data or use your own data, then simply you can use dialog. There are a number of videos on YouTube for how to use eViews for this, for that. So you can also use that. For such thing, you can at least you can use eViews or YouTube lectures, and there is a proper documentation of all the software also. So within after going into the software, you can use their own documentation system. The documentation system of UVUs data that is quite good. So you can take help of that. We don't have sufficient time here, otherwise. And there are some technical issues in Gradle as well. So I'm not able to demonstrate that, but you can use UVUs. Now someone has asked about the data entry software. Now, if it depends upon the type of data that you want to enter. If suppose you are entering a very small sample, either time series or cross-sectional survey data. If the number of observations are few, it may be 200. 200 is few. So you can use any software. Excel is good. Okay, Excel is very good. But if the number of observations are large, like 5,000, 10,000, 1 lakh, so in that case, you need sophisticated data entry based software. This data is there, SPSS is there, a number of other packages for other disciplines are also there. But if you are from economics and finance or all these backgrounds, I think Stata is good for data entry. I am using Stata since a very long time, last 15 years around. So, and also I have used other packages. So for most of the thing, I think Stata is a very powerful and easy to learn. When we move towards other powerful softwares, their programming is sometimes difficult, but Stata is quite easy. It is even easier than using dialog box after some time. So you can use Stata for that. Is for small data, everyone is good. Someone is asking which is best software for a small collection of data. A small collection of data, I cannot get it. What is the meaning of it? A small collection or a small data? Can you repeat your question? If data is small, all the softwares are good. There is no need to worry. You can use Excel. You can do lot of statistical exercise in Excel. Just add data analysis package in your Excel. Type on Google how to add data analysis package in Excel. Okay, then you can add. There is a inbuilt data analysis package in Excel. Okay, but it is not installed. You have to install it by going into options. So first learn how to install data analysis package in Excel, then install it on Excel in Excel. After installing, you will get a new option. In Excel, there is an option like home and number of other options. In the last, you will get data analysis. So there you can do regression analysis, you can do mean difference test, lot of things by even in the Excel. So if data is small, you can use any software. That is not problematic. The space when the data is large or complex, or there are a number of issues, then we need these softwares. Okay, so I think time is almost over. If there is any further question, kindly ask, then we can close it.
Hello, sir. Good afternoon.
Yeah, good afternoon, Ji.
Sir, one question.
Mm.
Difference between type 1 and type 2 errors.
Okay, type 1 and type 2 error.
Yeah. If you can repeat once again, we'll get it clear.
Okay, when we take decision with respect to hypothesis, with respect to null hypothesis, okay, there may be two types of error. One is that the stated hypothesis is true, okay. In reality, the stated hypothesis is true, but by mistake, after doing all the exercise, you are rejecting that. Hypothesis is true, but you are rejecting. So it is an error, okay. And this error is first type error, type 1 error, okay. Rejection of true hypothesis. A type 2 error is acceptance of false hypothesis. The hypothesis is false, but by mistake you are accepting that. So this is type 2 error. In hypothesis testing, the problem is that we cannot minimize these two errors simultaneously. Okay, there is trade-off. So either you can minimize type 1 error or you can minimize type 2 error. So we concentrate upon a minimization of type 1 error, which is known as level of significance. Okay, and we choose minimum level of significance, minimum chance of rejecting a true hypothesis. Okay. Clear? Okay, so I think there is no any further. Which error is most dangerous? No, I mean, as I said that it is subjective question. Like in court trial, we try to minimize the conviction of. 1 minute. Okay, so it is subjective, okay, and it is suggested in the literature that we must try to minimize type 1 error. It is more dangerous in a sense. When okay, someone is there from Kashmir and NSCI, so I also thank you all from Kashmir. Okay. Is there any other question? Anything related to software theory, method, anything. Okay, thank you all for listening me.
Yes, Tariq sir. I'm really
yeah.
still at
Are you
college.
there?
I was listening to your session,
Oh,
but couldn't respond because we were with the committee members.
okay.
Okay, so it has finished. I think the entire session has been over.
Yeah, it is over.
Okay, okay. At the end of the session, participants, I'm going to share with you the attendance link in the WhatsApp group, because we are occupied with one of the meetings at the college. It was an LIC meeting. So at the end of the session, I would like to thank Dr. Tariq Masood sir for taking out time from his busy schedule. I know it like 2 days, entire sessions he has taken so deliberately and with so much of patience. Sir, I'm very much thankful to you for giving our participants so much of time and so much in-depth information about both the very important topics of research methodology.
Thank you, Dr. Anna. I am thankful to you for inviting me, and I'm also thankful to the chairman, Shahid Saab. He was senior to me in the leader, and all the faculty members there. And I am also thankful to all the participants who have listened me, asked the question. Thank you all.
Thank you so much, sir. With this, we end up today's session, and participants, I'll be sharing with you the attendance link in a while. I think in the WhatsApp group only I'll be able to share because still the meeting is going on. I just came out of the session to wind up the today's session. Okay. Thank you, Tariq sir. Thank you so much, and
Thank
hope
you.
to see you again in one more session. And I
Yeah,
hope that we
inshallah,
can collaborate
inshallah.
further in future as well. Okay, sir.
Sure.
Thank you, sir. Take care. Bye.
Vice Chancellor Punjab University. पता है आप ये सिकंदर विकंदर आए ना पता है तो ऐसे ही बता रहे हैं नियम पर की रात से बता रहे हैं एक्सीडेंट होना है इसको बाय चांस पर एक्सीडेंट नो बला को जिस बात सुंदरवार है हुचे मैडम सर वास्ता है वो बात के काम क्या करे से चलो काम आस्ते शुरू वहीं से रेडी मतलब मुझे नजर है मैडम ना बात करे सेजी डिसाइड बिल्कुल सर मगर फिर टीचर जरूरी है ऐसे एलियर तो मैं मायर की मस्ती जावा निदात नहीं होना निदात टीचर सही है निदात से तो बारात है ना